Okay. So today's topics we're going to see about ensemble learning techniques. So it is also supervised machine learning. So ensemble learning means it has a multiple models. So ensemble learning means it has a multiple models and train combined together and to predict the output. So that is called ensemble learning. Again, I tell you. So ensemble learning is a n number of or multiple trained models can combine into the to predict the output. Okay, so listen Alka. So first one is bagging. I tell you, so bagging has there are training, these are the training data set, these are the training data set. So this is for Alka and this is for Gautam and this is for Vasant. Okay, so we are using decision tree algorithm, right? So we are using decision tree algorithms. So Alka is using maximum depth is 3 and Gautam is using maximum depth is 2 and Vasant is using maximum depth is 1. Okay, but the prediction is who have the highest percentage, then only it is the output. So we can give us most frequent or else average prediction. So if Alka have 0.99 percentage and Gautam have 0.97, so Vasant have 0.95, so which one is highest, Alka?
Yeah, 0.98, I think the first
So
one.
no, 0.99. This is
99, yeah.
0.99, 0.88. So if you both people have 0.99, so it means, so this is the most frequent, right? So most people are getting the 99 percentage of accuracy, right?
Yeah.
So this is a bagging concept. Okay, so it's like a parallel. So these are the data are parallel. Okay, so come to boosting. So just remind Alka. So first, this is a training data set. You people are making the decision tree, like a maximum depth is 1, but your prediction, so you people are only getting 70 percentage only. So then only we are going to moving on. Again we want to change the data set, not we change the data set, so again we change the algorithm. So we will
Listen,
update.
listen.
So if you're using, so
Just
we
hello.
is Alka.
Actually, there is a call from my daughter's school. Just a minute, I need to take it.
Yeah, okay, Alka.
Yeah, just a minute.
So in boosting concepts, so we will give the training data set. So we will applying our algorithm. So this is the decision tree algorithm. So we are applying maximum depth is 1, but our prediction is 70 percentage. Okay. So because our output is not perfect for 100 percentage, right? So then only again we will update the decision tree. So the maximum depth is 2. So now our prediction is now it's in a 90 percentage, but we want to better accuracy, right? So again we will use the same decision tree, so with the high maximum depth. So again we will try to predict the our output as a 99 percentage. If your output is 99 or 100, so it is for good prediction for us. Okay, do you have any doubts, Alka? So boosting is like a sequential, like it's one by one. So boosting is like a sequential, but so bagging is a parallel. So it to find the best one. Have you got this structure understanding?
Bagging is parallel, and here, there is majority of like
Yes.
you have given example 99%. So this is the prediction, right?
Yes, Alka. So I'll
Okay.
give
For
yes, I will give you another example. Like we are using one by one, right? So if I conducting Mark one, so if I conducting Mark one, you people are getting in normal percentage. Okay. So again and again I will continue the mark. So our score will be one. It increases to perfect
it's
reach the
yes,
accuracy, right?
it's like updating something, getting more accurate in any result, in any
Yes,
prediction.
Alka. Yes.
Okay. Yeah, no doubt.
Oh, okay. Okay, so and the next one is stacking. So here we are using different algorithms. So here we are using different algorithms. So one is so wait a minute, Alka. See, so here we are applying different trained data set. So here I given different, Alka, it's not a three, okay? So it may have four, it may have five. So I just given the example for three data sets. So these are the trained data sets and we are applying different algorithm. So first one is decision tree and this is for k nearest value. There are many algorithms there, Alka. So in your side, you people are know logistic regression, decision tree and support vector machine and what are the ones are remaining there? Linear regression. Okay, so you can use any algorithm, but you have to see your prediction which one is better. Okay, so which is the highest accuracy now? 90
Yeah,
percentage or
99.
99? 99. Okay, so we want to combine all this output and using another algorithm. Okay, so this is a linear regression. So this is a linear regression to find the best answer, to predict the best answer. Okay,
Mm.
it means we are trying different algorithm, but he is the main thing. Okay, so meta learner is the main thing to learn the prediction concept. Have you got my point? These
Got
are
it.
the base learners. So these are the base learners. So base learners have ideas only, but meta learners to fine tune the answer. Have you got it?
Actually, stating I did not get. These
Sorry,
are
sorry,
base
Alka.
learners. So, yeah, this one I'm not getting.
Okay, so in
Mm.
stacking, we just give the training data set and we are applying different algorithms. So different algorithms. So in these algorithms, we call it as base learners. So we call it as base learners. Okay. And in this algorithm, we call it as meta learners. So meta learners, they will help to combining all the algorithms to predict the best output. Have you got my point?
Okay, so here we are applying different kind of algorithm, and this is the main. It's combining all these three, and then we are getting
Yes,
prediction.
yes. We will see a
Yeah, yeah,
theory
got it.
concept, Alka. You can easily understood. First, you have to understand this diagram.
Yes,
You got my
got it.
point? So bagging, boosting, and stacking. Okay. So Alka, you can take a screenshot. Wait a minute. Yes. Now you can take a screenshot.
Yeah, done.
Okay. Okay. We will continue. So let's see. So I already told, right? So Ensemble Learning is a machine learning, and here I already told multiple models. So we call it as learners are combined to solve problem together and to predict the best output. Okay. So it means a group of weak models can create a strong accurate value like that. Okay, so it means it reducing overfitting and it improves accuracy and it is more stable and reliable. Okay, so reduces overfitting means in our data set contains noises and duplicate data. So these are the data will reduces using ensemble learning and it improves our accuracy and it is more stable. Okay, so come to bagging. So bagging is a full stands for bootstrap aggregating. So it's mainly building for just imagine the diagram, Alka. Just imagine the bagging diagram so you can easily understand. So it builds multiple models are independently, right? So multiple models are independently, so and different random subsets of data. So final prediction is what it is averaged or voted. We can use regression or classification. It reduces variances. Okay, and so here we using random forest classifier, right? Yesterday I already
Yeah.
told, right? So random forest classifier means it's a majority voting or else highest frequent value.
I get it, I tell you,
Yes,
yes.
yes. And come to boosting, I already told that it's sequential like a snake. Okay. So models is a sequential and tries to correct the error alta. So once a time, it will correct the errors. So it will check the previous state. It will check the previous state and to correct the error, right? I draw the diagram, right? 70 percentage and 80 percentage and 90 percentage, right?
Yes.
Hmm. And here we are using it's used for bias and improves predictivity. So just to see, These are the examples: AdaBoost and Gradient Boost and SG, Light, GBM, and Cat Boost. I'll explain you AdaBoost and Gradient Boost later. So just the same concepts. Boosting is also all are same concepts, all are sequential. And the next one is stacking. So stacking means, Alka, I want to tell one thing. So just listen. So this is called stacking, Alka. So in your home, what's the structure of your idli cooker?
We are having different trays, like 3 or 4 trays
Yes, levels like so that is called
level.
stack. Okay, each and every plate has a stack. Just to see,
Hmm.
this is like a zeroth level. This is a level zero. Like it's like a decision tree. Okay, it's a level zero. This is level one. This is level two. Have we got it? In level 0 we have base learners. In level 1 we have meta learners. Okay. So another is prediction. So then only we call it as a stack. Okay.
Yeah, okay.
Okay. Then come to the point. So it's combining multiple models as a base learners and use another model is called what? Meta learner to learn how the best combining them. So you can use any algorithm, logistic regression, a support vector, or decision tree, any algorithm. So to find using meta learner, you have to blend them. You have to blend or mix them to find the best output. Have you got it?
Hmm. Yeah, got it.
It's a simple tips for you. So bagging is like a parallel. So boosting is like a sequential, and it is like a combined meta, like a bench
Fine.
model. So it means logistic support vector machine, random forest. These are base learners, and who's your meta learner? So linear regression.
Linear
Also,
regression.
any algorithm we can use as a meta learner. Only one algorithm we can use as a meta learner. Okay.
So meta learner can also be any algorithm, right?
Yeah.
Okay.
And base learner also you can use any algorithm.
Hmm.
But here there are more algorithms we can use as a base learners.
And as a meta learner,
Meta learner only one algorithms present.
yeah, one algorithm, but any algorithm.
Yes. N number of algorithms. So come to advantages, Alka. So it improves the accuracy and it handles overfitting and it works. Definitely it works well with high dimensional data. So high dimensional means I already told, right? So 1D, 2D, 3D, 4D, like that dimension data. So in disadvantage means so it is too complex and harder because it takes longer training time. Okay, which stacking is takes a longer time. Okay, it's only for stacking advantage and disadvantage. Okay, now we are briefly see about bagging. So I already told it's a bootstrap aggregating and it's one of the ensemble learning techniques and it trains multiple models as independent to random subset. In scene we lastly previously we seen as a average and majority vote. I already told, right, Alka, so it's repeatedly again and again. Okay, we got my point.
Yes, sir.
We'll see one example, Alka. So in SQL and Ensemble Learning, we are importing random forest classifier, and in dataset we are using load iris. Have you seen the iris dataset? Okay. Now only I teaching you, right? So train test split and accuracy. Okay, I'll tell you. First, you have see this. This is the iris flower, Alka. So this is iris. Okay. So first we have to import a matplotlib and image also, and you can read the image. You can download this image, Alka. So all are in one image only. Okay, this is in three subplot. All are in single image. Have you got it?
Okay.
Okay, so if you are given image, so it will shows the image. So here I off the axis. So because by defaultly it shows the axis. See. Yes, it sees the x and y axis, right? So then only off the axis. Just to see, there are three varieties. So iris, one is setosa, and another one is versicolora, and another one is virginica. Okay, so
So these all three are one image. All three are in one image, right?
is alcohol are in one image.
Okay.
Hmm. And I just differentiate for you. So you don't know which one is iris, which one is septosa, which one is vesicular. So they are checking their petals and sepals millimeter. I'll tell you. Just I will display the data set. Just import it and give it pandas and load iris. If you are given in data frame, then only it shows as a table format. Otherwise, it written as a array format. Okay. So here the iris data means x. X is the iris data, right? So which one is x1? So sepal length, sepal width, petal length, and petal width. These are the x, and species is the y. So this is the target value, and these are the input features. Okay. And iris feature names means it display the names. So these are the in centimeters, sepal length and their centimeter, sepal width and petal length and petal width. And another one is species. You can give the column and you can give the iris date, iris target value. So it only shows the binary classification, zeros and ones. We will give as a value. So we just mapping. Wherever the zero presents, we will change into setosa. Wherever the one presents, we will change into versicolora. Wherever it's changed into two, it changes a virginica. Okay. So if you are given df to string functions, it automatically display the data set. Have you understood this data set, Alka? So if it is in 5.1 centimeter and if it is in 3.5 centimeter, so we call it as setosa. So we want to find the all the inputs. Have you got it, Alka?
Yeah, so all species are Setosa.
Yes, Alka.
Hmm.
Have you got it?
Okay.
So another one is Alka. So now we will go this concept. You know, if you can simply load iris and return x and y equal to true means it automatically takes as a x and y Alka. It automatically takes as a x and y. Or else you can give this command. Okay.
So here x and y, x-axis or y-axis,
Yes,
or
yes, 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 x-axis, y-axis. Or else you can give like that. X is a iris data, y is a iris target. Or else you can give like that. So
okay,
now I given as a command line, so the code is not work now. Okay, so here I'm using three quotes, right? Three. This is a string. If I enclosed with the three quotes, it is changed as a command line alpha.
okay,
So now I given a train test split. So the 30% of data will go into for testing. Here I'm using the random forest classifier. How many decision tree I'm using in estimators?
100,
100 decision tree. So now my accuracy is what? 100
100%.
percentage. So have you got the point?
Hmm.
It's very easy, Alka. So this is the bagging technique, and another one is boosting. Let's see. So these are the ensemble learning techniques. So boosting means what? It's a sequential, right? So multiple weak learners is a sequential formed as a strong learner, right? So each new model corrects as the error made by what? Previous one. So it will check the previous one. And the advantage is it's a higher accuracy and it reduces bias and variance. So it works with imbalanced data set, Alka, and it too complex pattern. It's easily adapt, but it means if you are using the data like sequential alka, so it will takes time, right? It to run one by one, training one by one, right?
Yeah,
So then only it's slow and overfitting and it's harder to interpret for single model. So now let me see. AdaBoost means adaptive boosting, gradient boosting. I'll explain you. So these are the popular boostings which are using in the companies. Okay. But you have to knowledge in these concepts. So these are the same concept, Alka. So adaptive boosting also same boosting concepts. It's also sequential, combining by multiple weak learners to has a strong classifier. But here we using one level decision tree. One level decision tree means what, Alka? One level decision tree means it has one root node, two
yeah.
leaf node. So this is called what, Alka? One level
Okay,
decision
so
tree.
directly first level to last, like prediction.
Yes, yes, yes.
Okay,
So we call it as stump. We call it as stump.
done.
See here the spelling for stump. So we call it as decision stumps. It means one level decision tree. Okay. So it also assigning equal weights to all training alka. Assigning all weights. I told right. So if in your family members have three members are there, you are asking the decisions you want, those are Italy. So you are assigning equal weights, right, to all the training
Hmm.
example, right? But the
Yes.
weak learners has a decision stump. So decision stump means they have only option, those are Italy, right?
Yeah.
So if you are increasing the weights, it's misclassified. Then the weak learner is only for you. You are the weak learner, Alka. So
Hmm.
you now deciding. So which one is best? Or they are asking. You are asking them. Okay.
Hmm.
So which one is majority? Then only you will prepare for that, right?
Yeah.
So this is the rapid steps for fix to find the best final prediction. Okay, the same concept, Alka. Okay, and let's see how they are using AdaBoost classifier. How they are using AdaBoost classifier. It's a simple, Alka. So everything is okay, and the new thing is AdaBoost classifier from Ensemble Learning. It takes from Ensemble Learning. Okay, and see, we will give as a estimator. So decision tree classifier maximum depth one means what is the diagram, Alka? So it has a one root node and two is
To final leaf note.
child nodes, yes.
Yeah.
And we are applying AdaBoost classifier. Here you are given the node size. Here you given the decision tree. How many decision tree are they are expecting? 50.
50.
Now you are providing the learning rate. If the learning rate is 1, it's normally read all the data, Alka. If it is less than, the model is better, but it takes slower. So
Okay.
learning rate means, Alka, today you will prepare one topic, right? Yes.
Hmm.
In
Yes.
this week you people are prepare this machine learning concepts. But if I given a long time for machine learning concept, so what it happened? So in machine learning concept, I will give 2-3 weeks. What it happens? So your model accuracy is perfect, but it takes two time, is right?
Yeah.
If
It's
I
true.
if I given 5 minutes to prepare all the machine learning concepts, you people are only prepare little much, right? So the model is not perfect, right? So then only this is the normal learning rate, Alka. If it is less than one, so it is not good. So if it is greater than one, it's good, but it takes time. Have you got my point?
Yeah. Get it.
So we are just applying AdaBoost model, and if you are testing, the accuracy is what? 94 percentage. Have you got it?
Yeah. Got it.
Alka, if you are changing the estimator, it may be like 100 percentage also. Depends on your given content. So till what's the previous one? That's also 97, huh?
Hmm.
97.
But learning rate, when we change learning rate less than 1, then the accuracy should be
So see,
changed.
Alka, now it's a 94, right? Once I
Hmm.
change the estimator as a 100, it shows as a 97. But your accuracy should be high, Alka. But you have to understand these parameters, these hyperparameters, for tune the
So
model.
how? Yeah, but how estimator is changing the accuracy?
So Alka, estimator means your decision. You can give any how many you can any number of decision. You can give one or two or three. Your wish.
So now if we make it 100 and learning rate we make it less than 1, so the
If
accuracy
I
will be
given
less, more
200,
less.
now see
Hmm?
the outputs also 97 percentage only. If I given 100, it
And if
also
we change
means
learning rate, then
learning rate. Okay, I'll change the
yeah.
learning rate. Just a minute. Okay. You can give or less than one. It means 0.9. Hey, yes, your model is perfect, but so it missed some datas. Have you got my point?
Hmm.
Have you got it, Alka? You can change any parameters, Alka.
Hmm.
Okay.
Okay.
Have you got it?
Okay.
But
I'll
we
try.
want to higher accuracy. So just you have to understood this, then you can change the model and train the data set for 100 percentage. No issue. Okay.
Yeah.
And the gradient also same, boosting always it's a sequential. Okay, so it minimizing the loss function using gradient descent. So gradient descent means to find the error. Gradient descent means to find the error. This is the graph for gradient descent. So our loss is high. If our error is high, our loss is what, Alka? If our error is high and loss also high. If our error is
Yeah.
low, our loss also
No.
less. If there is no error, our loss is also there is no loss, right?
No.
The
Yes.
structure is a gradient descent, like it's a valley, a mountains valley, like in this structure. Have you got it? This is the graph for gradient descent, Alka.
Yeah. Okay.
Hmm. So then only they are mentioning gradient descent. So here also they are initializing constant prediction and they computing residual errors to find, they are finding the errors to recover. Okay, and they're reducing loss function. Again, it's the same concept. Slower training, the same thing. Okay,
What is residual error?
so
Whatever is left in that.
Alka, so in residual, we are seen in multiple linear regression, right? So this is the error term. It calculating the error term.
Okay,
It
fine.
may mean absolute error, mean square error, anywhere. Have you got it?
Hmm.
Hmm. It's okay. And the next one is now we are applying gradient boost classifier. Same thing here. We are given 100 estimator and learning rate. And what's our maximum depth here we are using? What we are using?
Yeah, it's true.
Yes. So alpha. So here, you can use any one algorithm is enough for us. Have you got it? You are learning now. So in this data set, which algorithm is suitable, Alka? In this data set, which algorithm is suitable?
Yeah, I think
So which one is 100% Alka? So gradient boosting is the
gradient
100%
boosting.
accuracy. And what about this? 94% accuracy, right? And what about this? Here also 100%. You can use any one algorithm, okay? But
So
you have to
this,
understood the concept. So I think the random first backing is enough for us, right?
yeah.
Hmm. Now you are learning, so then only you have to
So
learn all the
when
concepts.
we apply boosting, so have to apply all
No,
or
Alka,
anyone we can choose.
you can apply any one.
Yeah.
And the next one is
Just,
stacking. So I already told,
hmm.
right? So it's a multiple base learners can predict. So base learners from 0th module and meta learner from what? 11 module. So they are meta learner make the prediction, right? Final prediction, right? Yes.
Yes.
Now listen how the stacking work means. So there are multiple base models are there, same training data, but each base model makes as a prediction, right? Each base model has a prediction score value. Then meta learners
Yeah.
trying to predict the base model's features, right? Combining these prediction to find the final output, right?
Yes.
So in starting, I told the story, right. The same concepts will apply in theoretical also. If the interviewer asks any questions from here, you can search your first you can search your ChatGPT and prepare these concepts. Have you got it,
Hmm.
Alka?
Yeah, yeah, I will
So
prepare.
this is only theory concepts only. In interview point of view, you have another thing. Okay. Okay.
Another thing means theory concept we
Not
are having
theory.
here also, right?
So if I'm asking your self introduction, you will say
Hmm.
like question answering or theoretical.
Theoretical.
You are explaining theoretical, huh?
Yeah.
No, no, not like that, Alka. You can speak like a normal. So if you are asking me, so what is bagging? So I'll explain you clearly. Yes, right. So
Yeah.
you no need to explain detailing. So you have to explain what is what.
Hmm.
Have you got it?
Intro is also theoretical, right?
Result? Sorry.
Okay, the explanation is there. No, no, just nothing.
Yeah. Okay, Alka. No, don't worry. We will prepare. Okay. So the
Yeah.
next one is stacking, right? So stacking, so we are using support vector classifier and we are using stacking classifier and logistic regression. Let's see the code. And you know how to load the iris data and how to train them. So in base learners, so Alka, this is the dictionary Alka. So this is the dictionary format. This is also one of the dictionary format. Okay. So you are taking decision tree classifier as a DT. You are taking decision tree classifier as a
DT.
support vector classifier. Probability is equal to true as a support vector
SVM.
mission. Yes. So it's separating probability means what Alka? We have only zeros and ones, right?
Hmm.
One or else it reaches a zero or else it reaches as a one. Is right?
Yeah.
Okay, so come to meta learner, we are applying logistic regression. Now see, in stacking classify, what are the things we are applying? Base learners and meta learners. And cross validation is 5 times. So in our 10th class, definitely they have a cross validation in our marks, right? In our exam paper, right?
Hmm.
Once the teacher is correcting the paper, they have maybe mistakes, right? So again we
Yes.
will correction the same paper, we will find out the mistake, right?
Hmm.
Same thing here also, they are using cross validation. If first time the accuracy is 70 or 80 percentage, again we will use a cross validation, we will get more accuracy to better. So
Yeah.
check here also we were getting the 100%. All coding is same Alka. If you are good in regression and classification, it's really easy for you.
Yeah. Okay.
Hmm.
So the first one and last one is giving 100% accuracy, and Boolean also one of them. What was
Sorry Alka,
gradient?
I didn't get your
The
point.
first gradient Boolean was giving 100%
Yes, yes,
accuracy,
yes, yes, yes. You can
and then
any one.
this
You
one
can
and the
use,
first
yes,
one.
yes, yes. You can use
Yeah.
any one algorithm is enough. Depends
Okay.
on your project. Okay. So these are the ensemble learning concepts. Do you have any
But
doubts in?
how to find out that depends on the project which one have to use. Any one we can take.
Algorithm. So we are using depends on data set alga. So here we using iris data set, right?
Hmm.
So we have four or three inputs, right? Four or
Yeah.
three inputs, and we will get one output, right? So
Yes.
depends on here we are applying decision tree, right? So yesterday
Yeah.
we seen sunny rainy winter, right? So
Hmm.
and that time we are using decision tree and random forest. So in this kind of data set we can use like these data only.
Okay.
Hmm. Okay, I'll just scroll and stop the recording.